each atom has a unique number of bonds that it will always retain. So hydrogen can only ever have one bond. It can't have 0, it can't have 2, it always has to have 1. Oxygen always has to have 2 bonds. It's impossible for it to have 3. Nitrogen always has 3 bonds, and carbon always has 4. Now that we've discussed the different bond requirements, I want to go ahead and show you guys how this is going to be beneficial in understanding what monosaccharides need to do in order to become a disaccharide. So just for simplicity's sake, we're going to draw up a simple structure and just pretend that this is a monosaccharide. A monosaccharide is more complex than this. You can see exactly what it looks like in the next slide. But just for having a simple structure to demonstrate this process, we're going to pretend that this is a monosaccharide. And we want to go ahead and link it together with another monosaccharide in order to form a disaccharide. And if you take a look, each one of the atoms in this structure has its bond requirement met. Carbon has its 4 bonds like it's supposed to. Each hydrogen only has 1 bond like it's supposed to. And the oxygen has its 2 bond requirement as well. Same thing goes for our second monosaccharide. This one has all of its bond requirements met as well. So now we have 2 monosaccharides that we want to link together to form a disaccharide. So in order to do this, we would need to add a bond between them so that they are linked together and are now 1 unit instead of 2 individual units. Now, that being said, this wouldn't really work because if you take a look, this hydrogen already had its bond requirement met. It used its 1 bond to attach to oxygen. It doesn't have the capacity to have a second bond in order for it to use it to attach to this structure here. Same thing goes with this hydrogen. This hydrogen is only able to have 1 bond, like all hydrogens do, and it used it to attach to this oxygen. So we can't just add an extra bond in there because then it would disturb the bond numbers. And that's not something that can actually happen. Hydrogen can't carry more than 1 bond, so it wouldn't be able to just add a second bond and link them together. So instead what we would have to do is remove some of the atoms so that we can free up the bonds that are there and use the existing bonds to attach them to each other. So I'll show you guys what I mean. For example, we can go ahead and remove this hydrogen here, and that way the oxygen doesn't have to use its second bond to attach to hydrogen. We can just use the second bond to attach it to our second monosaccharide. So as you can see, we extended the bond. Now oxygen has its second bond attaching to our second monosaccharide. And so that worked. We were able to remove the hydrogen, free up that bond, and now this side of the structure is able to have its bond requirement fulfilled while still bonding to our monosaccharide. But if we take a look at this side, this wouldn't work for this side of the structure because the hydrogen on this monosaccharide is still carrying 2 bonds when that is not even feasible. Remember, hydrogens can only have 1 bond, and it already used its hydrogen to attach to this oxygen. So it's not capable of having another bond attaching it to our first monosaccharide. So what we would need to do is what we did the first time, which is remove more atoms so that we are freeing up more bonds and can link them together. Now, the way that the body is going to do this is using a simple process called condensation. Condensation is when we make water. We know water is made out of H2O, 2 hydrogens and an oxygen. So if we were to use the atoms from these structures to make water, we would have to take 2 hydrogens and an oxygen. So by making water, we are freeing up 3 bonds. Again, because we are removing 2 hydrogens and an oxygen, we are freeing up those bonds. And that should usually be sufficient enough for whatever we are trying to do. And so because of this, anytime we need to link 2 things together, the body will go ahead and perform condensation, because that will allow us to free up some bonds so that they can then link together. So let's go ahead and take a look at how that would happen. In order for us to make water, we need H2O. We already removed one hydrogen. Let's take that second hydrogen, and then we need oxygen. So now we have H2O, or water. Now, we've used those atoms up, so they're no longer part of the structure. So let's go ahead and remove those and see what we're left with now. After we remove those two hydrogens and oxygen, this is what we have left. So if we wanted to go ahead and add a bond to link them together now, let's go ahead and see if that would work. This oxygen has two bonds, one linking it to the first monosaccharide, the other bond linking it this way. That works. Oxygen is supposed to have two bonds, so that would be fine. We look at this structure. Carbon has 4 bonds. And remember, carbon is allowed to have 4 bonds. It's supposed to have 4 bonds. And so this would work on this side as well. So as you can see, after we performed condensation, we had removed enough atoms that there was room to add in a bond to hold them together without having to disturb that bond balance or the bond requirement. And again, this is going to be something that will happen anytime we need to link two things together. In this case, we are pretending that these are monosaccharides, but it doesn't even have to be carbohydrates. It could be linking together protein structures, fat structures, or really anything in the body. Anytime we need to link two things together, we need to remove some atoms first so that there is room for that bond to come in without disturbing the bond numbers. And so keep this in mind. We're going to see it in the upcoming chapters. You want to remember that anytime we want to link two things together, we need to perform condensation first. Now, the other thing is we now have our disaccharide, but let's say that we wanted to go ahead and split it into the two monosaccharides again. So we're just going to go ahead and remove that bond so that we have two individual structures, again, two monosaccharides. But if you take a look, this wouldn't work either, because that bond that was holding them together was fulfilling their last bond requirement. That bond was giving carbon its 4th bond. Now that we removed the bond that held them together, carbon only has 3 bonds. Same thing with this structure over here. Oxygen's 2nd bond was the one that held it together with the other monosaccharide. Since we removed that bond to split them apart, now oxygen only has 1 bond. So if we want to split something apart, we can't just remove the bond because we need to replace that bond with something else in order to keep that bond requirement fulfilled. And the way that we're going to do this is just reverse what we did in the first place. Because remember, before we made water, these two monosaccharides were able to exist on their own and had all of their bond requirements fulfilled. So if we just add water back, we can go ahead and fulfill those bond requirements again. So let's take a look at how that would work. We can go ahead and add 1 hydrogen here. Now this structure is fulfilled again. Oxygen has 2 bonds like it's supposed to. Hydrogen has 1 bond like it's supposed to. So we're good on that side. Now, water is H2O, so we still have 1 more hydrogen and an oxygen to use. So we're going to go ahead and add them to this side. And if you take a look, we have fulfilled the bond requirement here as well. Carbon now has its 4th bond met. Oxygen is supposed to have 2 bonds. It has those. And hydrogen is supposed to have 1 bond. It has its 1 bond. So by adding water back in, the two structures are able to exist alone as individual monosaccharides while still having their bond requirements fulfilled. If we just removed the bond, then the bond requirements would not have been fulfilled and those two wouldn't have been able to stand on their own. Now that we added water in, bond requirements are fulfilled again and they can stand on their own. The process that we just described is called hydrolysis. This term that you see up here, hydro stands for water. Lysis always means splitting something apart. So literally what the word means is using water to split something apart. And that's exactly what we did. In order to successfully split the disaccharide and still have the bond requirement met, we had to add water back in after removing that bond. And that's going to also be the case no matter what it is that we're splitting apart. So here we were splitting a disaccharide into 2 monosaccharides, but if we were doing the same thing with protein, fat, or any other structure, we would use the same process. We would have to add water back in to split them apart. So again, keep this in mind. We're going to say it over and over again. You want to remember that in order to link 2 things together, we need to perform condensation, which is when we make water. In order to split 2 things apart, we need to perform hydrolysis, which is when we add water. Now this slide shows us the same thing with the actual monosaccharide structures. So remember, what we drew up on the previous slide isn't exactly what a monosaccharide looks like. We just used it to demonstrate it in a simple way. But this here is showing you what monosaccharides actually look like and what happens when they join together. So you can see at the top we have 2 glucose units coming together, and in order for them to join together to form our disaccharide maltose, we needed to create water first. We needed to take those 2 hydrogens and oxygens and make water, and that allowed us to join them together. At the bottom, you see us breaking maltose into 2 monosaccharides. And what you see happening here is once we break that bond, they can't exist on their own without having something else fill that bond requirement. And the way we're going to do that is by adding water back in. So again, this is the same thing we just covered, so if it looks a little scary, don't worry about it. As long as you understand the concept that we discussed in the previous slide, then you're good to go for hydrolysis and condensation.